Hello everyone, this is Tanmay Vashista. I'm currently working as a project engineer with Swinton, and this paper was done during my master's research in conjunction with my advisor, Dr. Mohammed Mehany. The title of my paper is A Framework for Life Cycle Assessment and Cost Analysis of Precast and Cast-in-Place Buildings in the United States. During this presentation, I'll be going over introducing the topic, highlighting the research gaps, the formulated research questions out of those, discussing the research methodology in detail, touching base upon research and discussions, and in the end, highlighting the key conclusions. So starting with, the construction industry has a sizable environmental impact due to the use of materials, the resources, and the energy throughout the lifetime of a project, and a variety of broad spectrum off-site, on-site, and operational activities. As a matter of fact, 900 million tons of concrete is annually produced just in the United States. So the traditional construction method, the cast in place, has adverse environmental and economic impacts due to the on-site activities such as mixing, curing, and installing. In the meantime, precast construction gives lesser environmental and economic impacts, but they still have considerable impacts throughout the life cycle of a project during the installation and operation phase. Over a period of time, there have been two methods which have risen rapidly for evaluating the life cycle environmental and economic impacts. Those are LCA life cycle assessment and LCCA life cycle cost analysis. This research will be using these two methods to formulate a framework which can be applied to different building systems. Now on to the research gap. The authors actually conducted a little review where we found that there is a lack of study which integrates both the methods to calculate the life cycle environmental and economic impacts using cradle-to-grave approach in the United States. Cradle-to-grave approach is considering the processes from raw material extraction phase to installation phase to construction phase, operation phase, and thereafter the demolition phase. In addition to that, comprehensive framework to evaluate these life cycle impacts has still not been there yet so that we can compare different building systems at one point of time. Also, as I mentioned with cradle-to-grave approach, the phase-wise evaluation of the environmental and economic impacts of both these building systems has still left been unaccounted. So in order to target these research gaps, the following research questions were developed to develop a framework for evaluating cost and environmental impacts of precast and cast-in-place buildings over a complete life cycle using cradle-to-grave approach. Second, to derive a comprehensive system boundary to study the environmental as well as economic impacts of precast and cast-in-place buildings, which can actually serve as a future platform of research as well. Now, on to the research methodology map. This framework was designed keeping in mind the four phases, starting with the first phase of goal and scope definition. We defined our goal and scope restricting to these four phases: raw material extraction, precast installation, operation, and the demolition phase. It was followed by life cycle inventory, where the framework was developed keeping in mind of where the data sources will be collected. So data sources will be materials, transportation, construction data, operation, and the demolition. The second phase was followed by life cycle impact assessment and life cycle costs. This framework was developed keeping in mind that these things will be evaluated on a software called OpenLCA version 1.9.0 using a database called EcoInvent, and there are several impact assessment tools such as Tracy, CML, and ILCD, which can actually help us evaluating the environmental impacts throughout the life cycle of a project. Also, for the economic impacts, the results were double-checked manually using NIST LCC handbook as well. After this framework was developed, it can be applied to compare phase-wise. We can compare the environmental impacts and the economic impacts of all these four phases for different building systems, and the comparison of building system as a whole throughout the life cycle of a project. Now, the framework developed using keeping in mind these four phases can actually be applied to different building systems out there. This research was a part of phase one of my research, which is on its way of getting published, where we actually went ahead and applied this framework on precast building systems, cast in place, and precast with Chinese panels building system as well. Now, after this research methodology map was developed, these was the anticipated results and discussion for our phase one. However, we actually used the same table and the unit processes to go ahead with the phase two of our research as well. Now, going ahead individually with these individual phases, the first phase was raw material extraction and manufacturing, which consisted of producing a concrete, 1 cubic yard of concrete, and it included all the processes which required to produce concrete. And the resources selected were electricity, fuel, water, and transportation was included as well. Now, this research was actually done in OpenLCA software. Now, as you can see over here, we created a process called precast building. Thereafter, we added these inputs to our one building system, for example, precast building, and we added the amount, the unit, as well as the cost impact of those. So both the environmental and economic costs can added simultaneously in OpenLCA software. After these, the model graph for this particular phase shows that all these sides on the left-hand side are the input processes for just one particular phase, raw material extraction and manufacturing. Similarly, these was developed for the other three phases as well. Thereafter, we chose Tracy as our impact assessment tool to evaluate the environmental impacts. And these were an example of a snapshot of impacted results for one environmental impact indicator, such as global warming. Now, moving ahead to the other phase, precast installation or construction. Now, we know that for precast plant operations are done in the precast plant, wherever the cast in place is done on-site. The processes included setting up form of systems, rebar installation, curing, and placement of concrete. Wherever the same thing were happening on-site. The resources which were used as electricity, water, fuel, and building materials. So this was our second phase, precast installation or construction. Moving ahead to the last two phases, operation and demolition. For operation, annual energy consumption was calculated for both the building systems, and for the demolition, demolishing the precast and cast in place building components and after transferring them to the landfills was considered as a part of scope of study, the phase two of the project. Now, all this framework developed can be applied to all these four phases in a very comprehensive manner. Now, on to the data sources which we collected for second phase was for raw material extraction, bill of quantities, eco-envent database, and the project estimate from the GC. Construction phase was taken by general contractor, estimate, and the eco-envent database. For the operation, we actually double-check our quantities for the utility departments and energy modeling through Revit as well. For demolition, the data was taken from general contractor and eco-envent database as well. Now, moving ahead, as I already told, we actually calculated the environmental impacts. So being an LCA practitioner, we can use the framework to actually evaluate a lot many environmental impact indicators outside. These 9 indicators were selected as a part of our goal for the second phase of our study because these are recommended by US EPA. Now, moving ahead, that the conclusion of this paper was pretty much a comprehensive system boundary was developed using cradle-to-grave approach, comprising all the processes from raw material extraction phase to installation phase to construction operation and the demolition phase. Now, this applied developed framework successfully evaluate the life cycle environmental and economic impacts of different building systems. Also, the future scope of the study can be, we as a practitioner evaluated these life cycle cost and environmental impacts using cradle-to-grave approach. However, cradle to cradle can also be applied where we take into account the reuse and recycling aspects of precast as well. As we know that precast components can be recycled and reused as well, so this addition can actually give more angles or more aspects about the life cycle environmental and economic impact to the future research out there, to the research scholars and the industrialists as well. During the part of this paper, these were my main references, and thank you for this opportunity. If you have any questions regarding my research or my paper, you can reach me out to Tanmay 26 @gmail.com. Thank you so much and have a great day ahead.